Okay, well, we are back to work on some angle relationships. We did a lot of work with angles last time, um, classifying that, naming them, classifying them, angle addition, bisecting angles. Well, now we're going to talk about different angle relationships. So relating more than one angle to each other or together. And, this is vocabulary that you guys got a head start on, but let's run through it. Complementary angles, two angles whose measure total 90 degrees. So one is the complement to the other. It is not one angle, three angles, many angles. Complementary angles are two angles whose total is 90 degrees. Supplementary angles, two angles whose total is 180 degrees. Again, not one, three, or many, exactly two angles. One is the supplement of the other, and they don't have to be anywhere near each other. We can have one angle here and the other angle on the other side of the world. They could be 90 and 90, or they could be 170 and 10 degrees. Any two angles whose measurements total 180 degrees. So we have complementary angles and supplementary angles. Perpendicular lines. Now, even though we're talking about lines, it falls under angle relationships because the important thing about perpendicular lines is that they make a right angle. So we have a couple things going on here. The symbol for perpendicular, something you need to know. So, for example, segment LR is perpendicular to segment RP. That means that they form a right angle, and we can see the right angle box being used. And if it's a right angle, then the measurement of that angle is 90 degrees. We know that. So you might be told that the lines are perpendicular. Now you know that means it makes a right angle. Go put the little box. You might be shown the box, and now you know since it's a right angle, those lines have to be perpendicular. So it's not always going to come all as a package. They're perpendicular and they give you the box. They tell you one, you have to know the other. So the symbol for perpendicular lines, and again, that means that they form a right angle. And we might add that little right angle box by ourselves. We just have to know that. We have vertical angles. Vertical angles are the non-adjacent angles formed by intersecting lines. Very simply, vertical angles are the opposite angles from an X. So if you see an X anywhere, we have vertical angles. And they're the opposite angles of the X. Vertical angles are congruent. So looking here, YRK, angle YRK, and angle DRL. That is a pair of vertical angles. Those vertical angles are congruent and they have equal measurements. The other ones are true also. Angle YRD and angle KRL are also vertical angles. They are congruent and they have equal measurements. So whenever we have an X in the picture, we have two pairs of vertical angles. Vertical angles are congruent. Vertical angles have equal measurements. And we have a linear pair. A linear pair is always going to look like a Y. So vertical angles look like an X. A linear pair looks like a Y. And it is two angles that are adjacent and supplementary. So we talked about adjacent. Adjacent means that they share the vertex. So they share the vertex and the line that splits them. One of them goes out that way, the other one goes out that way. That's adjacent. The fact that they add up to 180, that's supplementary. So think about it. A straight angle is 180 degrees. So together, these make the straight angle YRL. So we can do some angle addition, but we could also say these are a linear pair. So again, the two small angles here are adjacent and supplementary. That's what makes a linear pair. When we know they're a linear pair, we know that they total 180 because by definition, they are adjacent and supplementary, meaning they total 180. So this is all vocabulary. This section is 99% vocabulary. Looking at a few examples here, we're asked to find a few things. So we're asked to find a right angle. We did this already. A right angle typically might have that right angle box, the indicator. So we can do something like angle JSL. Now there's multiple correct answers here. I'm just giving us something as an example. Number 2 asks for vertical angles. Vertical angles come from an X. So find an X in the picture. Anywhere you can find an X. So let me use the highlighter. Here's an X right here. So we want the opposite angles of that X. For example, maybe we'll take the top and the bottom angles. So angle YRJ and angle SRL. That's a pair of vertical angles. We certainly could have used the other two, the obtuse ones. So we could have said angle YRS and angle JRL. That's another pair of vertical angles. Complementary angles. Remember, complementary angles means two angles that total 90 degrees. And again, there's a few examples here. But one easy example is we have a big right angle here. And it was split in two. Well, that means together those two angles have to add to 90. So we might use the two little angles. We'll call angle 1 and angle 2. So complementary angles, as an example, we might say angle YLK and angle KLG. They're not the only pair, but that is a pair of complementary angles. Remember, complementary, two angles that add to 90. So we could not use a 90 on its own. We need two angles that add to 90. Supplementary angles, two angles that add to 180. Well, I see a 90 and I see another 90. 90 and 90 is 180. So let's use those. And again, there's multiple correct answers here. I just want to make sure we all get to see an example. So, for example, the yellow one is angle YLG. And its partner to add up to 180 is angle JSL. Now, they don't have to be 90 and 90. They just happen to be. We could have picked different angles. And I'm going to do that in the next one. A linear pair. Well, a linear pair also has to be supplementary. But now they have to be adjacent. The two that we just did were not adjacent. And if you remember our discussion, a linear pair is always going to look like a Y. So I'm going to find a big letter Y in the picture. So let's see. There we go. A big letter Y. So I'm going to use this angle and that angle. So a linear pair. The first one, PLG, angle PLG, and its partner, angle GLW. GLW. So I was just looking for the letter Y. And again, there's multiple of them. Let's see, another letter Y right there, upside down kind of. So we have angle SRL and angle LRJ. So if we know what to look for, we can find them. Congruent angles, remember, so congruent, when we have the arc on the angles, that usually means congruent, and sometimes we put the little hash marks on it. So we're talking about angle YLK and KLG. Angle YLK and angle KLG. Congruent segments. The hash mark says that they're congruent. So we have two segments over here with hash marks on them. I put one in green and one in blue. So congruent segments, we could say segment JR is congruent to segment, not angle, segment RS. And, even in the previous question, we could have used, instead of the and, we could have used that congruent symbol. So even on congruent angles, I can go ahead and just say, okay, they're congruent. And then finally, the last question here is about perpendicular lines. Well, or perpendicular segments. Remember, perpendicular lines make right angles. So look for your right angle. If you can find a right angle, then you can find perpendicular segments. So for example, here, we have a right angle right there. So that means segment JS, for example, is perpendicular to segment SL. Now, I could have called it SL or SP or WP, right? So I could have said something like JS is perpendicular to segment WP. Wherever they touch each other makes a right angle. That's all that means. So perpendicular lines form right angles. Let's look at these questions here. Focus on what they gave you algebra for. Not what the algebra is or even what you're looking for, but focus on what did they give me algebra for. Angle MSL. MSL. LSP. So now we have to figure out what to do with them. Well, if I look at that picture, they're a linear pair. We can observe that. So what does it mean to us? We have a linear pair, which means they're adjacent, which they are, and supplementary. Supplementary means two angles add to 180. So that's what we're going to do. We're going to take angle MSL, add angle LSP to 180 degrees. One definition leads to the next. So we observed that we have a linear pair. By definition, that means they're supplementary. By definition, that means they add to 180. So that gives us the equation. Now we're going to substitute MSL is 6x plus 20. LSP is 2x, and that total is 180. So we have 8x plus 20, 180. 8x is 160, and x equals 20. We were asked to find angle MSL. So we're going to take angle MSL is 6x plus 20, and we're going to plug that in. 6 times 20 plus 20, and we get 140 degrees for angle MSL. In number 2, I'm just going to give myself a little bit more room here. Find the angles that they gave us algebra for. That's all I care about. YRK. YRK. Angle DRL. Angle DRL. They are the opposite angles of an X. They're vertical angles. And vertical angles, we know our definition. Vertical angles are congruent. Well, that tells us what to do. Angle YRK is equal to angle DRL. They're congruent, and their measurements are equal. So let's just plug it in. 5x plus 15 equals 4x plus 25. We'll work out a little algebra here. X is 10. And let's see what we were asked to find. I'm going to say plug it in everywhere. And then we'll figure it out. So we have 5 times 10 plus 15. This is YRK. So that's 65 degrees. Well, if we plug it into DRL, we're going to get the same thing. We know that. 4 times 10 plus 25 is 65 degrees. They're congruent. They're vertical angles. So we were asked to find DRL. We got it. Angle DRL is 65 degrees. We were also asked to find KRL. KRL is right here. We don't have that one yet. But look at it. These two angles are a linear pair. Cover half the picture. Angle YRK plus angle KRL has to equal 180. So 65 plus angle KRL equals 180, which means angle KRL equals 115. And then again, that's degrees. So we have our two answers that they asked for. There's multiple steps. This is problem solving. One definition leads us into another. Find x, plug it back in, step back, and reassess what you actually have to do. Let's see what else we have. LS and MP. So remember what that symbol means. They're congruent. LS and MP are congruent. Well, I'm sorry, not congruent, perpendicular, right? Perpendicular, which means we have a right angle. So let's put the little box. Now we don't have to keep track of it anymore. And if it's a right angle on that side, it's also a right angle on this side, right? There's no secret. We just don't overload the picture. So angle TSL, and angle PST. Well, together they make that right angle. That's exactly what we're going to do. Angle TSL plus angle PST makes the 90 degrees. And again, we know it's 90 degrees because those lines were perpendicular. A little substitution. A little bit of work here. And we got x. Of course, we're going to reread the question, and it says find TSL. So that's 3 times 10 plus 20. And we have 50 degrees for angle TSL. And our last question here, I'm just going to scroll up and give us a little bit more room here. We have a vocabulary word. And what does supplementary mean? Well, supplementary means two angles that add 280 degrees. And they gave us both the angles. They gave us STP, so that's 8x minus 15. And they gave us ABC, 4x plus 27. We're adding them to 180. It's 12x plus 12, 180. 12x, 168. Divide by 12. X equals 14. But we were asked to find STP. So we're not done. Angle STP is 8x minus 15. 8 times 14 minus 15. Well, that's 80 and 32. That's 112 minus 15. And we get 97 degrees. So we found angle STP is 97 degrees. We were also asked to classify it. Classifying means what kind of angle is it? Well, it's an obtuse angle. It's greater than 90, but less than 180. So we get an obtuse angle. So this is all about vocabulary that we have to have pretty solid. All right, let's do some more practice.